This is trig number 7, and it's the law of sines. The law of sines is actually quite difficult, but when you see these problems, you're going to realize that you can do them. So let's start with what the law of sines is. It's the sine of A, capital A, over lowercase a, equal to the sine of B, again a capital B, over a lowercase b, equal to sine of C, capital, over the lowercase c. I don't like the c as much because it's hard to tell the difference between the capital and the lowercase. The next important element to the law of sines is the diagram. Notice this is the first time since we've been studying trig that you do not need a right triangle. In fact, the law of sines works on a non-right triangle. The angles get labeled with the capitals. So this angle is labeled A, capital B, and capital C. Then the sides opposite those letters receive the lowercase. So A across from this, or the opposite side, becomes the lowercase a. Opposite from the capital B becomes the lowercase b, and I don't like that either because it starts to look like a 6, and it's not. It's supposed to be a lowercase b. And likewise with the C, where it is a lowercase c, notice it is across from. If the side is across from the angle, is it an adjacent side or an opposite side?
Opposite.
Opposite, right? It means across from in geometry. So here's a couple of problems. Let's start with the first one. And we'll start by writing the law of sines, and we only need 2 of these. So we'll say sine A over A equals sine B over B. Now we'll fill it in with the corresponding information. So sine of 42 degrees is across from the side that's labeled 15. Likewise, the sine of 37 degrees is across from the unknown length, which we'll call x. Now we need to do some algebra to rearrange the equation. We'll multiply both sides by x, and x over x will disappear. We'll multiply both sides by 15, so the 15s will disappear. Then we'll divide both sides by the sine 42 degrees, here and here, so that the sine 42 will disappear on this side. Notice there's only the x left. So x will be equal to 15 times sine 37 degrees over sine 42 degrees. Do you have your calculators ready? Hold it up when you get a value and I'll see if it looks like the right one. Not yet. What have you got? Anybody else? Not yet.
Oh.
What do you got? Natalie, are you trying? All right, so let me talk you through it. You ready? Are you saying 15 times 37 sine equals, because you needed to execute that multiplication step. Then you say divided by 42 sine equals again. Yes, that's it right there. 13.49. Who doesn't have it yet? And who has an Android? So for yours, did you say 15 times sine 37? But you need to close the parentheses before you say divided by. Who didn't get it that's trying? Okay. So for you, same thing, might be a parentheses problem. Clear it? Make it degree. Good. Now try. 15 times. Sine 37. Now here, make sure to close the parentheses. Now say wait. Okay, fine. Now say divided by. And do the bottom, do sine 42. There you go. Okay, how about this? You got it. How we do it? Oh, you got it. Oh, you got it. Okay, ready? Say 15 times 37 sine. There say divided by 42 sine equals. Oh, who else? Did you try it, Tiffany? You got it? Did you try it? Did you get it?
Yeah.
Did you get it? Did you try it? Did you get it, Miss Shane? I don't know how to say Shane. Okay, while you're typing, where are you? Turn sideways. Is that like an intro? Looks like an outfit, right? Alright, so for you, do 15 times sine 37. 37. Parentheses. Good. Now divided by sine 42. Should be it. Yeah, 13.49. All right, ready? Start with the law of sines first. So sine A over A equals sine B over B. Let's fill in sine of 39 degrees over 29 equals sine alpha over 25. Now we need to do some more algebra. We're going to multiply 25 by both sides. It's gone here. I'm going to say sine alpha on this side is equal to this statement. 25 times sine 39 degrees divided by 29 And then we need to do the a sign or inverse operation of the sign and move it over to this side and say sine to the -1 parentheses all of this. 25 times sine 39 degrees over 29. There we go. And we say alpha is approximately equal to. Ready? This ought to be even more challenging. This is a 29 right here written. Poorly. Poorly written. This is a 25 in the parentheses. 25. This sine to the -1, you'll use your second menu. The second menu. Get. We're not going to retry. I think you've got to do it backwards. You've got to start way over here on the inside and say 39 sine times 25 equals, divided by 29 equals, and then say second -1 sine. Work from the inside out with your iPhone.
I think you got it right though.
That looks kind of right. Try it again. You, okay, ready? Say 39 sine times 25 equals, divided by 29 equals, second sine to the -1.
Oh, okay.
32.86. Yes, I'm rounding the 5 up to 6. Who hasn't got it yet? Okay. Do several equals. In this sequence here, do 39 sine times 25 equals, then divided by 29 equals. You do second sine -1. Good. Then say 25 times sine 39. Yeah, I want to get rid of that parentheses there. Touch it here. Okay, so just straight times this. This parentheses is for this function. So say time. Now say sine 39. Now parentheses. Now divided by 29. And the Android seems easier. Clear that out. Say inverse sine. Sine is -1. Here. Now say 25 times sine 39. Parentheses divided by 20. Go. Ready? Do 39 sine times 25. Equals. Good. Now divide by 20. Equals. Now second. Yes, you got it. Yes, ready? You're my last one. Clear? Alright, so 39 sine times 25 equals, divided by 29 equals, second, that makes this into a sine to the negative 1. Yes. There you go, it's the law of sines.